Good morning, friends. In the previous lecture, we continued with the remainder theorem of how to divide two polynomials and how to find out the remainder by using that remainder theorem. Now, in this lecture, we are going to continue with the next topic, and that is the factor theorem. Factor theorem, right? Now, in the previous topic also we discussed about the division of the numbers, that how two numbers are divided, that we studied in the previous years, that is in the lower standards, right? Let me take for example, if I divide 63 by 7, then what I am going to get here? Let me divide here 63 divided by 7, so that will give me 7 into 9, simply 63. The subtraction will be 0 here, right? Let me take another example, that is 84 divided by 5. If I divide this 84 by 5, what I am going to get is 84 divided by 5, that is 5 into 1 is 5. The subtraction here is 3. 4 is being taken down, that is 6 into 5, or 5 into 6 is 30 with a remainder of 4, right? That means in both of these divisions we are getting different answers. Suppose if I write these both in the form of, right, in the form of what? In the form of dividend equals to divisor into quotient plus remainder, right? So if I say that dividend is equals to divisor into quotient plus remainder, then the first one, the answer to this first one can be written as 63 is equals to 7 into 9 plus 0, and the second one can be written as 84 is equals to 5 into 16 plus 4, right? Now what does these two say us? That 63 can simply be written as 7 into 9, but 84 cannot be perfectly divided by 5, right? 84 cannot be perfectly divided by 5 because it gives us a remainder of 4 here at last. Yes or no? And as we can say that the second one has a remainder, that means 5 is not a factor of 84, right? What do you mean by this factor? Factor simply means that the number that is dividing, must be present in the dividend, or the number that is being divided. If 5 is present in the factors, that means in the numbers that we can write 84 as simply the multiples. If 5 is present over there somewhere, then it is a factor of 84, and if it is not present, that means it is not a factor of 84. Here the 7 is a factor of 63, right? It is a factor of 63 because 63, if I write 63, that is going to give me 3 into 3 into 7, or 9 into 7. That means 7 is present there. That means 7 is one of the factors, or 7 is a factor of 63. But in the second case, 5 is not a factor of 84, because when you split out 84 as the product of some numbers, some integers, you will not get 5 anywhere, right? Let me say that 84, the factors or the product of integers, of 84, that is 2 into 42, 21, 3 into 7. So 7 into 3, 21 into 2, 42 into 2, 84. See, is there any 5 present over here in these multiplication? No. That means 5 is not a factor of this product. That means 5 is not a factor of this 84, right? the main thing that goes behind this is we can find out the factor easily. This, we are talking about the numbers. We can find out the factors easily simply by dividing them, right? That if we want to know that is 7 a factor of 63, then let us divide that 63 by 7. If I divide this 63 by 7, I'm going to get a quotient 9 and the remainder 0. That means whenever in a division, if the remainder becomes 0, then the divisor is a factor of the dividend, right? Let me write down here for general solution that the solution from the first one, it gives us if remainder is equals to 0, then divisor is a factor of dividend, right? Divisor, that means the number that is dividing. Dividend, that means the number that is being divided, right? Divisor will be a factor of dividend. And the second one, if remainder is not equal to 0, then divisor is not a factor of dividend, right? If remainder equals to 0, then divisor is a factor of dividend, and if remainder is not equals to 0, then the divisor is not a factor of the dividend. These questions are asked, check whether 7 is a factor of 63 or not, check whether 5 is a factor of 84 or not, right? The reason behind me solving these sums here is that now we are going to not deal with the numbers, but now we are going to deal with the polynomials as we seen in the remainder theorem, right? So let me say, or let me take some examples of the polynomials and then we shall come on to the factor theorem. I'm going to keep this as it is so we can come again to that conclusion itself. Right, now let us quickly recall the remainder theorem that we have studied in the previous lecture. Remainder theorem states that let p of x be any polynomial of degree greater than or equal to 1. Right, let p of x be, let me write down here, remainder theorem. Let p of x be any polynomial of degree greater than or equal to 1 and a be any real number. If p of x, that means the polynomial that we took here, is divided by the linear polynomial x minus a, then p of a is the remainder. Right, then p of a is the remainder. P of a simply means, friends, the value of x that we get from this x minus a, that means x equals to a, will be replaced in p of x in place of x. That gives us p of a. Right, so now we are going to look whenever we get any linear polynomial as a divisor and any of the polynomial having degree greater than 1 as p of x, that is as the dividend, then we shall simply look at p of a as the remainder. Right, now let me say, for example, here we are having x cube plus x square plus x plus 1 is divided by x minus 1. Then I need to find out the remainder. So simply here, what is the condition or what is the thing given here? Here g of x is equals to, here g of x is equals to x minus 1. Let g of x equal to 0. Therefore x minus 1 equal to 0, and hence x equal to 1. That means if I say that I am going to find out now p of 1, that is 1 cube plus 1 square plus 1 plus 1, that is 1 plus 1 plus 1 plus 1, which is equals to 4, right? So this p of 1 is equals to 4. Hence we can directly come to a conclusion that the remainder is equals to 4, right? So we got the remainder here, that when we divide this x cube plus x square plus x plus 1 by x minus 1, we will get a remainder 4. We simply know this. Okay, now what happens when this remainder gets 0? Right? Let me say that if I am having a question here with the same question, if I say that I am having this linear polynomial as x plus 1, then what? Then the solution now becomes that here g of x is equals to x plus 1. Let g of x equal to 0, therefore x plus 1 equal to 0, therefore x equals to minus 1, right? And now we need to find out p of minus 1, that is minus 1 cube plus minus 1 square plus minus 1 plus 1, that is minus 1 cube minus 1, this will be minus 1 square plus 1, again plus minus minus 1 plus 1, minus 1 plus 1 minus 1 plus 1 cancel, and hence we get the remainder as 0. Yes or no? See friends, in both the cases I am having the same polynomial p of x, but I have simply changed the divisor polynomial, that is the g of x. So in first case, when I was having x minus 1 as my divisor polynomial, I got the remainder 4. In the second case, when I am having my divisor polynomial as x plus 1, I got the remainder 0. So this simply comes to a conclusion, both the solution comes to a conclusion that the second one, we can say that, hence we can say that x plus 1 is a factor of the polynomial or of the given polynomial x cube plus x square plus x plus 1. Yes or no? How? So the simple reason behind this is this: if the remainder is 0, then the divisor is a factor of the dividend. What is this remainder? Is this thing 0? Yes, it is 0. That means the divisor. What is the divisor here? X plus 1 is a factor of the dividend. What is the dividend here? X cube plus x square plus x plus 1. So basically, what does this conclude? That again, what we did in division of numbers, the same thing we are going to process here for the division of polynomials. So using this remainder theorem here, this remainder theorem is being used here, and first of all we check that are the remainder 0 or not. Once we get the remainder 0, then we can directly conclude that the given g of x, the given divisor, is a factor of the p of x, the given dividend. Is it clear, friends? So from this conclusion we can say that x plus 1 is a factor. But here this is the remainder 4. Hence, coming to the second point, if remainder is not equals to 0, then the divisor is not a factor of the dividend. Is it clear? So this was the best example that I had here right now. Now you can check out for the rest of the examples that we solved in the previous case, that means the previous topic in the remainder theorem. Note that this factor theorem can be applicable only and only when there is a linear polynomial. I shall write it down, I shall note you, right? I shall make you note that what is the main limitation of this both, right? So I am removing this, and let us proceed to the factor theorem, the statement of the factor theorem. Then we shall solve one or two more of the same kind the examples, right? Okay. Now the factor theorem, what does this say? Let the statement, see friends, this statement is very important. It will not be asked, but again this can be useful for you to understand the perfect theorem, right? Let p of x be a polynomial of degree greater than or equal to 1 and a be any real number, right? Let p of x be a polynomial of degree greater than or equal to 1 and a be any real number. See friends, this first statement is same in both the factor theorem and the remainder theorem, right? Then there are two sub points in this. The first one, if this happens, then let p of x be a polynomial of degree greater than or equal to 1 and a be any real number, then the first one, x minus a, is a factor of the polynomial p of x if p of a is equal to 0, right? So what is this p of a? That is the remainder. So if remainder is equals to 0, then x minus a is a factor of the given polynomial. And second one, that p of a is equals to 0 if x minus a is a factor of p of x, vice versa, right? So the first one gives us x minus a is a factor of p of x if p of a is equals to 0, and the second one gives us p of a is equals to 0 if x minus 1 is a factor of p of x. See friends, this first and second points, both the points are vice versa, opposite of each other. That means if the first one is true, then the second one is going to be true, or if the second one is true, then the first one is going to be true. That means x minus a is a factor of p of x if p of a equals to 0. Again coming here, if p of x is divided by the polynomial x minus a, then p of a is the remainder. Now if that remainder is 0, then x minus a, friends, this x minus a is taken from here, the linear polynomial, the divisor polynomial. Okay, so if p of a, if that remainder is 0 in the remainder theorem, then this divisor x minus a is a factor of the p of x, the dividend polynomial. Or if p of a is, if x minus a is a factor, first we say that I'm given that given x minus a, given divisor polynomial is a factor of the dividend polynomial, then simply let us take p of a is equals to 0. So you need to understand this much only. Is it clear? You need to relate both of these theorems together. First of all, the remainder theorem, and second one is the factor theorem. Is it clear, friends? Right? Okay. Let us solve one example here itself so that we can come to know that how it can be solved. Check whether x plus 2 is a factor of polynomials x cube plus 3x square plus 5x plus 6 and 2x plus 4 or not. You need to check whether this x plus 2, see friends, we are only given one of the polynomials x plus 2 and that is a linear polynomial, right? Check whether x plus 2 is a factor of polynomials this and this or not. So first of all we are having two p of x's, right? So first of all we shall take the first one. Here g of x is equals to x plus 2. Let g of x equal to 0, therefore x plus 2 equal to 0, therefore x equals to minus 2. That means this x equals to minus 2, we got the value of a that we are talking here. This a be any real number, that means this x equals to minus 2 here is the value of that a. Okay, now we shall find out whether this is a factor or not. How to check whether this is a factor or not? If p of a is equals to 0. So first of all, in the first one, for p of x is equals to x cube plus 3x square plus 5x plus 6, we shall find out p of minus 2, that is minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. Yes, so minus 2 cube, that is equals to minus 8, minus 2 square is 4 and 4 into 3 is 12, minus 2 into plus 5, that is minus 10 plus 6. So minus 8 plus 12, that is 4, 4 minus 10 is minus 6 and minus 6 plus 6 is 0. So we get p of minus 2 equal to 0 in the first one, right? P of minus 2 equal to 0 in the first one. And similarly for p of x is equals to 2x plus 4, we shall find out p of minus 2, that is 2 into minus 2 plus 4, that is minus 4 plus 4, which is equal to 0, right? So simply we again got p of minus 2 is equals to 0 here also, and that is my second one, right? That is my second equation. So from equation number 1, equation number Roman 1 or smaller I and 2i or 1 and 2, we can say from 1 and 2 x plus 2 is a factor of given polynomials, right? X plus 2 is a factor of given polynomials, and that is the solution. So first of all, what we did, friends, first of all we got that linear polynomial out. Let g of x is equals to x plus 2. We found out the value of a or x equals to something, right? We found out the value of that variable. Then turn by turn or simultaneously we put that value of x in the given two polynomials. The first one here we got 0, the second one here we got 0. From 1 and 2 we can say that x plus 2 is a factor of the given polynomials, the polynomials that are given to you. It is a factor of the given polynomials. Is it clear, friends? Right, so this is how we can check whether the first polynomial is a factor of second polynomial or not. Okay, so now I shall erase everything here and then we shall solve some sums. See friends, if you want to write down, then please make a note that you can simply pause the video and then you can write it down, right? There is no need that I am not giving you some time to write down, because this is simply an offline video. There is no need to hold here and waste any time. Okay, now the next kind of sum is see friends, in the last lecture we solved a sum here. Let me say it. Check whether 4t cube, or let me write down 2t plus 1 is 4t cube plus 4t square minus t plus 1, minus 1 itself, is a multiple of 2t plus 1 or not. Multiple, that simply means the factor, right? Check whether this 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1 or not. Multiple simply means factor, right? Is a factor of 2t plus 1 or not, or it is a multiple of 2t plus 1 or not. So here we solved this already, friends. So here g of t is equals to 2t plus 1. Let g of t equals to 0. Therefore 2t plus 1 equals to 0. Therefore t is equals to minus 1 by 2, right? So we got the value of t, that is minus 1 by 2. Now p of t is equals to 4t cube plus 4t square minus t minus 1. Therefore p of minus 1 by 2 is equals to 4 into minus 1 by 2 cube plus 4 into minus 1 by 2 square minus 1 by 2 minus 1, that is 4 into minus 1 by 8 plus 4 into 1 by 4 plus 1 by 2 minus 1. See friends, how it is minus 1 by 2 cube equals to minus 1 by 8, that we have already discussed in the previous lecture. You can simply check that out. Again, this 4 in it can be cancelled by 2, 4 and 4 can be simply cancelled. So that is minus 1 by 2 plus 1 plus 1 by 2 minus 1. Minus 1 plus 1, minus 1 by 2 plus 1 by 2 is 0. Hence p of minus 1 by 2 equals to 0. So yes, what we can say from this is given. Hence 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. Is it clear? So that is the conclusion. Friends, this is how you can also check whether the given polynomial is a multiple of the second polynomial or not. The third question, find the value of k. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k, right? This is another kind of example that is being asked in the factor theorem only, right? Factor theorem, again let us discuss what the factor theorem, let us recall it. let p of x be any polynomial of degree greater than or equal to 1 and a be any real number, then the first case is x minus a is a factor of p of x if p of a is equals to 0, and p of a equals to 0 if x minus 1 is a factor of the polynomial p of x. We shall use that second condition here, friends. Given, what is given? X minus 1 is a factor of this polynomial p of x, right? So simply relate that second condition, that p of a is equals to 0 if x minus 1 is a factor of x minus a, x minus a is a factor of the given polynomial. We shall simply relate that much, right? So again read out, let p of x be a polynomial of degree greater than or equal to 1 and a be any real number, then p of a equals to 0 if x minus a is a factor. So given x minus 1 is a factor, right? So what will be the solution here? Will be given x minus 1 is a factor of 4x cube of, let me write down, p of x is equals to 4x cube plus 3x square minus 4x plus k, right? Given x minus 1 is a factor of this, then p of 1 will be equal to 0. Yes or no? This is the conclusion here, that p of 1 will be equal to 0. How, friends? Only p of 1. So will this x minus 1 will be taken as let g of x is equals to x minus 1. Therefore let g of x is equal to 0. Therefore x minus 1 equal to 0, and hence x equals to 1, friends, right? We will say that this value of x is equals to 1. Okay, so x equals to 1 will give us p of 1 is equal to 0. Therefore finding out 4 into 1 cube using this relation plus 3 into 1 square minus 4 into 1 plus k equal to 0. Okay, 4 into 1 cube, that is 4, plus 3 into 1 square, that is 3, minus 4 into 1 plus k equal to 0. So you can simply cancel 4 and minus 4. Therefore 3 plus k equal to 0, and hence k equals to minus 3, right? So we got the value of k, that is minus 3. Okay, friends, so that is how you can find out the value of the value of the unknown constant or unknown coefficient given to you in the polynomial, given to you in the p of x, given to you in the dividend polynomial. Okay, friends. Is it clear? Okay, so let me erase this. Now you can also check for some of the examples given to you in the textbook, and you can also check for the examples that we solved in the previous topic, that is the division of polynomials, where we have the divisor polynomial as a linear polynomial only. Note that, friends, main limitation of what? Limitation of factor theorem and remainder theorem. This is the main thing that you need to understand for a factor theorem and remainder theorem, that it is applicable, it is to those division of polynomials where the divisor is a linear polynomial. Understand, friends, that whenever the divisor polynomial, the g of x, is a linear polynomial, then and then you can apply this remainder theorem and the factor theorem. Else you cannot apply this remainder theorem nor the factor theorem in the examples. Is it clear? So the divisor polynomial must be a linear polynomial. Okay, friends? Okay. So recently we solved 3 examples related to the factor theorem. Okay. Now we shall solve some more of the examples here related to the factor theorem. Now in these examples we need to check whether the given factor or the given polynomial g of x, the fourth one, examine or determine which of the following has x plus 1 a factor. So friends, see, this x plus 1 is common here, right? What is common? X plus 1 is common here. Now whether we need to check that whether x plus 1 is a factor of this given polynomial or not, then how to check it? Like, we can simply find out that let x plus 1 equals to g of x, or let g of x is equals to x plus 1. Therefore, taking g of x is equals to 0, that means x plus 1 equals to 0, and hence x equals to minus 1. Now we shall look for such polynomials in which we say that x equals to minus 1 satisfies the given polynomial. If x equals to minus 1 satisfies, or if we get the value of that given polynomial equals to 0 at x equals to minus 1, then we can say that it is a factor, else it is not. Now the first example that I am having is that we have already took, friends. The first one is x cube plus x square. Sorry, my mistake. Let me write it like p of x equals to x cube plus x square plus x plus 1. So we are having a value of x here. Therefore, p of minus 1 equals to minus 1 cube plus minus 1 square plus minus 1 plus 1, that is minus 1 plus 1 minus 1 plus 1, that will give me 0, because minus 1 plus 1 is 0, and again minus 1 plus 1 is 0. So p of minus 1 is equals to 0. So the first statement of the factor theorem, hence x plus 1 is a factor of the p of x, right? X plus 1 is a factor of the p of x. Let me solve one more. The second one, there is a term here added, that is p of x equals to x raised to 4 plus x cube plus x square plus x plus 1. Okay, good. Now we are having a polynomial this given, therefore we shall find out p of minus 1, that is minus 1 raised to 4 plus minus 1 cube plus minus 1 square plus minus 1 plus 1. right? What is minus 1 raised to 4? That is 1. This will be minus 1, this will be 1, this is minus 1 plus 1. So you can simply cancel minus 1 1, minus 1 1. So the remainder is minus 1. Therefore P of minus 1 equals to 1, which is not equal to 0. Hence x plus 1 is not a factor. Hence x plus 1 is not a factor of P of x, right? We cannot say that x plus 1 is a factor of the P of x, of the polynomial P of x. Is it clear, friends? So in this way we can decide whether x plus 1 is a factor of the given polynomial or not. I am having one more of the same kind. That P of x is equals to x cube minus x square minus 2 plus root 2 into x plus root 2, right? This is the example that I am having here. X cube minus x square minus in brackets 2 plus root 2 into x plus root 2 again. Now we need to check whether x plus 1 is a factor here or not. Therefore we shall find out P of minus 1, that is minus 1 cube minus minus 1 square minus 2 plus root 2 into minus 1 plus root 2. Because friends, see, in place of x we are going to put minus 1. So here there is an x present. So in place of x I have put here minus 1. Can I take this minus 1 here before the brackets, right? That is minus 1 cube minus 1 square is again 1, but there is a minus present outside the bracket also, so that will become minus 1. This minus into minus 1 into 2 plus root 2 plus root 2. Okay. So this minus minus will become plus, minus 1 minus 1, that is minus 2 plus 1 into 2 plus root 2 plus root 2, right? That is equals to minus 2 plus 2 plus root 2 plus root 2 plus 2 minus 2 cancel, that is equals to 2 root 2. So we got the value of P of minus 1, that is 2 root 2, which is not equal to 0. Hence we cannot say that x plus 1 is a factor. Hence x plus 1 is not a factor of the P of x, right? Hence x plus 1 is not a factor of the P of x. So this is how we can check whether the given polynomials are a factor or not. Okay, now coming back to some important topic, some serious work that is to be done here in this chapter. Again, it is related with the factor theorem only, about the factorization of a quadratic polynomials. How to factorize a quadratic polynomial? I think you might have studied in the previous classes about how to factorize, right? So coming to a serious job to be done here, that is the factorization of quadratic polynomials. Factorization of the quadratic polynomials. How to factorize? In this topic we are going to study the method of this factorization by splitting the middle term. Now you might come with a doubt that, sir, what is the middle term? So first of all, let us see what a quadratic polynomial is. How can a quadratic polynomial be written? I think we have already discussed this in the topic, that is classification of polynomials. So a quadratic polynomial or quadratic polynomial is a quadratic polynomial has degree 2, right? Has a degree 2 and has a general form p of x is equals to ax square plus bx plus c. This is the general form of a quadratic polynomial. P of x is equals to ax square plus bx plus c, right? Where ax square is the first term, bx is the middle term and c is the last term, right? Ax square is the first term, bx is equals to middle term and c is the last term. So we are going to simply split the middle term such that we must get a common factor there. Common factor, yes friends, common factor there. Now how to get this common factor here is how to get this. Let me say, for example, I am having an example here. First one, that is p of x is equals to 6x square plus 7x plus 15. So first of all, the very first step number 1, multiply the coefficient of first term and or with the last term. Multiply the coefficient of the first term with the last term. So if I go on multiplying the first term with the last term, what shall I get here? Here we get 6 into 15, that is 15 into 6, 90, right? We get the answer as 90. So here in this example we got the answer as 90. Multiplying the coefficient of the first term with the last term, we get it as 90. Now since we get the product of first and last term is 90, now we are going to factor or factorize. Step number 2. This was the step number 1, right? Sorry friends. Step number 2, factorize. We shall now factorize 90. Factorize this number 90. So all the possible factors that we must get here is how? So factorizing 90, we shall get 90 can be written as 9 into 10. First of all, let me start with a smaller number there. That is 1 into 90, 2 into 45, 3 into 30, 4. Can this be divided by 4? No. 5? Yes. 5 into 18. Then 6 into 15, as we already got. 7, 8 and 9. 9 into 10. It is 90. Right? Now we need such an answer where we get the answer or the sum of the coefficients is 7. Is it possible for me to get it as 7? No, it is not possible, right? So how can we divide this, or how can we factorize this? We must get a number here. So see friends, we cannot get any of this addition as 7 here in this quadratic equation here, sorry, quadratic polynomial here, right? So for that, what is the next step to be done is we simply need to okay. So what is the thing here, that we simply need to get the answer, the total of 7. Here it is not possible. So the factors, hence coming to the conclusion, hence there is no common factor of the polynomial p of x, right? There is no common factor of the polynomial p of x. But what if I say that, what if I say here that it is possible for some another questions also? How? I'm having second example here, that is second one. P of x is equals to x square minus 5x plus 6. Right? X square minus 5x plus 6. Then is it possible for me to factorize here? Let us go step by step. So the very first step here will be multiplying. See friends, it is not compulsory to write this like step by step, right? I am going to write here because I need to make you understand. In the next sums I will not write it here, we shall directly solve here. Multiply the coefficient of the first term with the last term, right? So we get here as 1 into 1 into 6, that is equals to 6. Now factorizing this 6, so this can be written as 1 into 6, 2 into 3, else 3 into 2 will be the same thing. If I write 3 into 2, that is again 2 into 3, or 3 into 2, it is same. And if I write 6 into 1, that is again same as 1 into 6. So there is only two maximum possible factors, 1 into 6 or 2 into 3. What if I find minus 2 into minus 3? That will be again 6 only, because minus 2 into minus 3, minus minus plus, and 2 into 3 is 6. So simply you can say that, you can simply now say that the factors of 6 is 2 into 3, where we get 2 plus 3 as 5, right? Hence x square minus 2x minus 3x plus 6, right? Check it friends, minus 2 minus 3, that is minus 5, and minus 2 into minus 3, that is we got it as 6. So we shall now add a minus sign here, that is taking, you can take out x common here, that will be x minus 2. You can take out minus 3 common here, that is x minus 2. Hence we shall get x minus 2 as a common factor multiplied by x minus 3, right? Now this was the factorization. How we can check it for, are we getting any solution or not? How to check it? So all the possible factors of 6 are 1, 2, 3 and 6. Yes or no? Right? Similarly we can also get it like minus 1, minus 2, minus 3 and minus 6 also. Is it clear friends? So How can this be possible? I'm going to erase this here. This was the factors that we got, P of x. I think you might have studied in the previous classes also that how to factorize the polynomials, right? We got 6. Therefore, this 6 here, I'm writing it again here. This 6 can be written as a multiples. Multiples of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 itself, right? Now we shall check it for each and every one, whether for 1, minus 1, 2, minus 2, 3, minus 3, and 6, minus 6. When we get x equals to 2, let use that P of x, finding out P of 2. That is 2 square minus 5 into 2 plus 6. That is 4 minus 10 plus 6, which is equals to 0. Similarly, taking x equals to 3, P of 3, that is 3 square minus 5 into 3 plus 6, that is 9 minus 15 plus 6, which is 0. So we got P of 2 equal to 0 and P of 3 equal to 0. This simply means, using the factor theorem again, that simply using the factor theorem that P of a equals to 0 if x minus a is a factor of the given polynomial, or x minus a is a factor of the given polynomial if P of a equals to 0. Here P of 2 is equals to 0. Therefore, from this I can write x minus 2 is a factor of P of x. Here P of 3 equals to 0. We can write x minus 3 is a factor of P of x. Friends, you can similarly check out for the other things also, that are we getting 1 over there? 1 minus 5 plus 6, that will become 2 minus 1, if we check it for minus 1, that will become 1 plus 5 plus 6, that is 12. If we check it for minus 2, I shall get 4 plus 10 plus 6, that is 20. If we check it for minus 3, then I shall get it 9 plus 15 plus 6, that is 30. And if we check for 6 and minus 6, then also we are not going to get the answers as 0, because this only two values of the multiples of 6 are such where we get the value of the polynomial as 0. Hence, x minus 2 is a factor of P of x and x minus 3 is a factor of P of x. That is combinedly proved here that x minus 2 and x minus 3 are the factors of P of x. Is it clear, friends? So in this way we can find out the factors by splitting the middle term, and in this way we can find out the factors simply by finding out the multiples and then using the factor theorem. Is it clear, friends? So this is the example. The first example was such where we did not get any of the multiples, neither we got any of the factors. So that was a limitation to a quadratic polynomial, that it cannot be factorized because we had all the terms as plus, right? There must be a term minus, or there must be a coefficient of x square lesser than the coefficient of x, such that you can get the proper multiples of the given polynomial. Is it clear, friends? Okay, so I think this might be clear to you. Let us solve one or two of the same type, then we can come to a conclusion that are we getting the point or not. Okay. The third example, P of x is equals to 2x square plus 7x plus 3. I'm having this polynomial right now with me, right? And I need to solve this here. Then can we solve this or not? First of all, check it by the factorization. So let us first of all factorize this. We shall, what do? We shall split the middle terms here. So first of all, the very first step is multiply the first and the last term, or the coefficient of first term with the last term. So that is 2 into 3, 6. I need all the possible multiples of 6. That means multiples of 6 again. That is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Right? These are all possible multiples. Now splitting the middle term, I need the sum of 7. So can I write 6 plus 1, 7? And 6 into 1 is 6. Therefore, P of x is equals to 2x square plus 6x plus x plus 3. Right? See friends, this 7x is being now split here as 6x plus x. So the middle term is being split. Middle term is now split. 7 is written as 6 plus 1. Okay. So that is, you can take out 2x common from the first and second. That will give me x plus 3. And there is no need to take anything common from the third and fourth terms. That will give me x plus 3 again. So that is x plus 3 a common factor, and 2x plus 1 as another factor. Okay. Now when I come to a conclusion here that if I want to write down x plus 3 into 2x plus 1 such that I can get the remainder 0, then what can we get? Because in the possible multiples of 6 we have only written the integers. That is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Then in this factors we are going to get some another multiples also. That is something about plus or minus 2, plus or minus 1 by 2, plus or minus 1 by 3, and something else. But is it possible to write there? Yes or no? Yes, it is possible to write it down, because we might also get there 0. So one more multiple here, plus or minus 1 by 2, plus or minus 1 by 3 is also possible. You can check it out friends, whether are we getting the answer or not. Right? So that is 9 plus 2, 11, and 11 plus 7, 18. 18 by 3 is 6. Yes, we get the multiple as 6. Now what we shall do is, we shall simply get the values here, possible or not. Now we shall check for some values. We shall check for some of the values from these multiples possible. For that we are getting the value of P of x 0 or not. So for that what we shall do, first of all let x equals to minus 3. If I take x equals to minus 3, friends, see this is already verified by me, right? So there is no such thing that how to select the value or not. You can simply randomly select the values and then you can start solving. So let x equals to minus 3. So P of minus 3, that is 2 into minus 3 square plus 7 into minus 3 plus 3. So minus 3 square is 9 into 2, 18. 7 into minus 3, that is minus 21 plus 3, that is 0. Hence we get P of minus 3 is equals to 0. Right? P of minus 3 is equals to 0. Now we shall check for that integer value also. So let x equals to minus 1 by 2. If x is equals to minus 1 by 2, then P of minus 1 by 2 will give me 2 into minus 1 by 2 square plus 7 into minus 1 by 2 plus 3, that is 2 into 1 by 4 minus 7 by 2 plus 3, right? You can cancel this 2 and 4 by 2, hence 1 by 2 minus 7 by 2 plus 3. What is 1 by 2 minus 7 by 2? Minus 6 by 2, and that is minus 3. So minus 3 plus 3 is equals to 0. So we got P of minus 1 by 2 is also equal to 0, right? Hence, if P of minus 3 equals to 0, then the conclusion being x plus 3 is a factor of P of x, and if P of minus 1 by 2 is 0, then x plus 1 by 2 is a factor of P of x. See friends, we got x plus 3 is a factor, that is confirmed, but what about x plus 1 by 2? So if I take 2 common here, x plus 3 into 2 into, it will give me x plus 1 by 2 again. So now it has been confirmed that x plus 3 and x plus 1 by 2 are both the factors of given polynomial here, that is written in the board. It is clear friends, right? So that's it about how to factorize a polynomial by splitting the middle term and also by verifying the values from the factor theorem. Is it clear friends, everyone?